Welcome to LabMinutes.com. In this video, we will look at one of the two ways of configuring NAT on a Cisco ASA version 8.3 and later, called Object NAT. The second method is what they call twice NAT. We will look at that in a separate video. First, we take a look at the new command syntax of the Object NAT. So basically, you start by configuring or defining an object network. You give it a name, and then next, you can either define a host, a subnet, or an IP range of the real IP of your device. And then you configure a NAT statement with the real interface, the map interface, and you specify what's the mapped IP you want your device to be NATed to. The same syntax can be used to perform both source NAT or destination NAT. For source NAT, the real interface would be your inside, and the map interface would be your outside. But for the destination NAT, you just basically reverse that, so it will be a NAT outside interface and the inside interface. For the Object NAT, there's really no way of matching or performing translation for both source and destination at the same time, because the command syntax doesn't let you specify source and destination in the same command. If you need to do that, you need to look into the twice NAT, which exactly allows you to do that. So you can look at the Object NAT as a very basic sourced NAT or a destination NAT as a separate process. And you cannot really do a policy or conditional NAT where you have to define both source and destination at the same time. So the matching process will happen separately. If you have a statement for a source NAT and there's a match, the source IP would get translated first, and if you so have a destination NAT configuration and there's a match, and the destination IP will get translated as a second step. When you configure multiple Object NAT, the order will get, or the configuration will get reordered automatically by the ASA, just like the pre-8.3, where the ASA was trying to put the most specific configuration at the top, and anything that's less specific will be down at the bottom. Unlike the twice NAT that you will see later in my other video, you have to manually reorder the NAT configuration, because with 8.3, what happened is you have a big NAT table, and the ASA will step through it from top to bottom. Anything get matched first, the ASA will use to perform the translation. But with the Object NAT, you don't really need to worry about putting them in the correct order, because the ASA takes care of that automatically for you, which is kind of nice. So now let's get started with our lab. Here we have a setup with the switch 1 on the inside, and it has multiple loopback address that's we're going to be using as the emulated host, and we use that as the source to ping the outside. In the middle, of course, we have the ASA firewall that we're going to be using to configure all the NATs. And on the outside, we have a router R2 with a loopback address that we're going to be using for our test ping. So we have a separate NAT scenarios that we have lined up here. So we're going to step through that one by one, starting off with Static NAT. So let's do that. Here I'm on switch 1 just to show you. We have a couple of loopback. Actually, it's IP interface brief. On the firewall, we have two interfaces configured for inside and outside, and then R2. There's very minimal config that we have. Okay, so our first NAT scenario is going to be static NAT, so we're going to try to translate a 32.32 to 1.32. But before we do that, let's make sure that we have an access list configured. So when we're trying to initiate a ping from the outside or R2, it will be allow. Okay, so start with access list. Just going to call it from outside permit IP any, And again, here also just to let you know that the one of the new feature that was introduced, or a change, not really a feature, a change that was introduced in the version 8.3 is the IP that you specify in your inbound access list. That's actually the true or real IP of your device. So with pre 8.3, you actually need to allow the NATed IP or mapped IP of your device, but with after or starting 8.3, you actually need to specify the real IP, which is I would say it's there's a pros and cons to that. The pros is if you ever need to change the mapped IPs on your device, you don't really need to update your access list. But at the same time, the cons would be if you need to update your internal the real IP of your device to get mapped to the same IP, then you need to update your access list. So here we have created from outside or inbound ACL to allow anything to talk to our internal 16.32.0 subnet. So now we're just going to apply that access list to the interface, and our interface, just to show you name if, just call that simply outside and inside. Okay, so let's start our first NAT scenario configuration, the static NAT. First, again, to the object. As you can see, if you're trying to tap, it would not complete anymore because there's ambiguous with the either option object or object group. So here, you type in object network, and we're going to give it a name. Usually I like to code a name with either a word mapped or real, so you know if the object is being used for the mapped or real IPs. So here we're just going to call it mapped 111.32 with the host. So just to show you different options, you can put description on it, you can specify a single host IP, or you can do a range, which is again kind of new to this 8.3. So it doesn't really need to do by subnet. You can just specify the range if you want, which we'll use that later on. And then there's a subnet. So firewall 1 host. Here we're just going to do the host 172.16.32.32, which is our loopback 0 on switch 1. Okay. And next you specify the NAT command inside the object. So here, just going to do in, out for inside, outside, and you can either do static or dynamic. So here we do static. With the map IP, you can just specify the IP here, or you can create a separate object or object group and associate it with the NAT statement. Or if you want to do a PAT, you can just tie that to the interface of your choice. So here we're going to simply do an IP, and you can do DNS. So if there's a DNS resolution passed through the firewall that matches your NAT statement, it will get fixed. And here's something that's just has been introduced at the software version 8.4.2, which is no proxy ARP. You can't individually disable proxy ARP on the NAT command, on each NAT. And then you can also force route lookup. So basically tell the ASA to use the routing table to route the packets, the NATs. So you're just going to simply do DNS. Okay, so that's in place. You can do show NAT. And here you can see Object NAT by default get puts into section 2. So there's a total of 3 sections, the NAT table 1, 2, and 3. And the object NAT just happens to occupy section 2. So whatever you put with the object network command will be placed in section 2. Okay, you can see there's counters in here that we will see the increments in a second. And you can still do show xlate, and your static NAT will show up in there. Okay, now we hop back to the switch. Let's perform some pings. So we're going to ping the R2 interface, sourcing from loopback 0. Actually, we should have run debug IP ICMP so we can see what IP the R2 is seeing coming from. So ping again, R2. Now see that IPs that's coming from is 111.32, which is our NATed or mapped IP. So if we do show NAT, you can see there are a total of 6 translated hits. Okay. Next, we're going to try, instead of doing a single host, we're going to do a subnet, which is equivalent to a network static NAT. So first, let's remove the object that we created. So delete that. And then we're going to do object network, call something like map static. And here we're going to create a range of subnet. .111.67. Okay. And the other option is for you to do a subnet and then do 111.64 with 255.255.255.252. Well, here we're just going to show you how to do the range, use the range command. Then we do object network map 111.64 through 67. And here we also going to use range command again. That represents our real IP, which is 16.32.32 up to 16.32.35. So you need to make sure the range of IPs on your real on the map IPs are identical or has the same size. So here we're dealing with 4 IPs. Then we do a NAT inside, outside, static, and here we just use the object group that we find earlier. Static, just do DNS again. Okay, do show NAT. That's what we have. Then we go to switch 1 and do a test ping from loopback 0. See now the R2 shows the IP is coming from 111.64, which is the first IP in our range. Okay, it maps to 32.32. And next we're going to try to ping from loopback 1, which is 32.35. And now it picked up the 3 IPs later, which is .67. So 32 and 35 is the 3 IPs apart, and that also gets reflected on the mapped IP. Okay, so that's the network static NAT. Okay, so next NAT scenario is going to be static PAT or port forwarding. So we have 32.37, which is loopback 2, and we're going to open up telnet service on the switch by having that map to a 111.37 with the port 2323. Okay, so the way to do that is you go object network. So everything always starts with object network. Map, let's call it 111.37 with port 2323. You're just going to do one host, 16.32.37, and then NAT inside, outside, static 111.37. And here we have an option of service. So we're going to define service, and it's a TCP service. You can see it says specify real TCP port. That would be 23, which is the real telnet service on the switch. And then it said specify mapped TCP port, and it's 2323. Okay, so that's the end of the command. Now let's try from R2. Just to show you the access list that we configured earlier, since we have not tried to initiate any connection from the outside, so far we did not have any hits. Now on R2, we're going to telnet to 111.37.23.23. Okay, now we get a password prompt, enter the password, and now we are on the switch number 1. And if you look at the access list, you can see that there's hit count 1. And if you look at show NAT, there's here's your translation right there. So show connection. Okay, here's your connection from the R2 outside to the inside port 23. And you can do show xlate as well. Okay, you can see the untranslated hit. That means it's coming from the outside up here. If it's inside out, it would be translated hit. So, okay, so that's for the PAT. Let's exit. Next, we're gonna do Dynamic NAT. So we're gonna use our 3239 IPs as our test IPs, and we're gonna create a NAT pool of 96 through 98, and the IP should pick up the IPs from the pool in a round robin fashion. So on R2, actually on firewall 1, go back, define more object network. Here we're going to define a NAT pool, so we're going to call it NAT pool. Range 96 through 98. Here we go back to object network. We call it map 111 96 through 98. With the host, if it's a subnet, you can specify the subnet. But here our test IP is just a single host, so we do that particular host 32.39, and then again NAT inside, outside. But this time, instead of doing static, we're going to do dynamic, since we're doing dynamic NAT here. And if you specify a single IP, it's going to become a PAT, which we will see in a second. Next example, here we're going to tie it to an object or an object group. So the one that we created earlier is called map NAT pool, and just going to do DNS. Okay. I don't think I've shown you the command show run object. One thing to note here is when you do show run object, it would not show you the NAT command under each of the object network. So when you do show run object, you don't see that command. It's normal. You have to do show run NAT. So there'll be identical object network. Specify under there, and it's your NAT statement. So you kind of have to match them up. Okay, so for our dynamic NAT, it's right here, 96 to 98, and here is our source real IP. Here's our pool that we're going to use. So let's do some tests. We're going to test from 32.39, which is loopback 3. So ping 111, source from 3. Okay, and it looks like it picked up 1.97, which falls within our range, 96 through 98. If we do show NAT, see dynamic NAT, get one translated hit, show xlate. So right here, 32.39 picks up 97. Okay, so if we do clear xlate, now that's gone. Let's try again using a ping from switch 1. Now I can see R2 seeing a ping coming from a 1.98, so it picks up the next available or next IP within the pool. And to show xlate, now 32.39 is NATed to 1.98. Okay, so that is for Dynamic NAT. Next we're going to try PAT, and we're also going to look at a new command called PAT pool that was made available in 8.4.2. So first we're going to look at a conventional PAT, which is multiple inside IP gets NATed or PATed to a single outside IP. So object network. Here we're just going to call it map PAT pool, so just to keep the name the same, and later we try the PAT pool. But we, instead of specifying multiple IP, we're just going to do one right now to do a conventional PAT. And then on the object network, map. So we're going to be using two IPs to test in this scenario. Let's look back real quick. We're going to use 41 and 43, which is Loopback 4 and Loopback 5. At first we're going to use just 111.128 and specify the range 111.128.111. Actually, no, that's not right. It's real IP. So 162.1632.41 to 1632.43. So you can see it's kind of nice with the range command. You don't need to specify a set of IPs that needs to fall within the subnet boundary. So you can pick any range of your choice. So here we have 41 and 43. NAT inside, outside with dynamic. Map PAT pool and DNS. Okay, so now we're trying to ping from Loopback 4. Actually, let's try Telnet, so the connection stays pinned up. Loopback 4. Let's give it a second. Let's come back and take a look. You can see the PAT is created already, but the Telnet session hasn't gone through yet. So you can see here we use 32.41. So if you see the port, that means it's a PAT. So because the PATs also translate the ports, but let's do that again. Next time it went right away. If you go Cisco, now you get drops into R2 and you do who. Errors coming from 111.128. Okay. So if you look at the port, it looks like the port that the device is trying to use is still available, so the port doesn't really get translated, but the IP did. So 32.41 to 1.128. And that's confirmed from the session that we locked in on R2. Okay. So next let's switch to Loopback 5. Here we get that get through right away. So let's look at the translation table. Here's a PAT. 32.43 gets translated to 1.128 also. Okay, so back to that who. The who command is 1.1.1.28. Okay, so that is conventional PAT, where multiple IP gets translated to a single IP that's specified, with the port potentially translated as well. Now we're going to look at the new feature called PAT pool. So what PAT pool allows you to do is defining a pool of IPs that you can use for your PAT, and instead of what it used to happen was it would not, the device with the ASA would not hands out the IPs, the next IP that you define for the PAT until you actually run out all the ports, which is 65,000 something ports of the first IP before it will roll over to the next IP. But if you have a needs to randomly pick an IP for your PAT from the pool while each of the IPs has yet to be exhausted, then the PAT pool is what you need. So back to firewall 1 configuration, we're going to modify, look at our Object NAT network that we create here, PAT pool. We're going to, instead of doing a single host, we're going to do a range. It says being used, so instead, let's delete this for now. Okay. Then delete that. Okay. Now we're going to do range 128.129, and let me put that back in for our test range, and then back to our NAT command, inside, outside, dynamic. And here, as you can see, as soon as you do dynamic, there's additional options called PAT pool. So you can do PAT pool, and then you specify an object, which is map PAT pool, and after that, you can see a whole bunch of more options. You can either do DNS, you can make an extended entry on the NAT table, so not only it will show the sourced translated ports, it will also look at the destination ports. For flat, you can tell the NAT to use the whole port range, 1024 up all the way up to 65,535. And you can use the interface as the backup IPs if you want. And you can tell it to do round robin fashion when it tries to fetch an IP from the pool. So here we're going to do that. Specify round robin. Okay, might even as well specify flat. And DNS. There you go. So clear xlate just to make sure. Then we're going to telnet again from Loopback 4, which is 32.41. Get drop right away. And then we do who, pick 111.128. Okay, let's exit. And then try from Loopback 5. While we're waiting, let's jump and look at the xlate table. You see the entry is already created for the Loopback 5 or 32.43 and gets mapped to the outside of 1.129, which is the second IP of that pool. So not sure why it doesn't really go through the first time, but I'm sure it will go through the second time. As you can see, the NAT entry is already created in the NAT table. Okay, so here you can see with the port show up, that implies as a PAT. Okay, that came back. Telnet second time went through right away and do a who, and it shows 111.129. Okay, so here that's for the conventional PAT and the PAT pool. The last scenario we're going to look at is Identity NAT, which is also called self-NAT, since the IP doesn't really get translated, or translated, but it's translated to the original IP. And that is pretty straightforward with the object group network. Well, let's try. Yeah, that. Well, actually, we skipped destination. Hang on, let's go back and go to the destination NAT. So the next one is the destination NAT. So what we're going to do, we're going to make the outside IP 222 appears as if it's the inside IP 172.1696.32. So first we're going to go with object group, or object network rather, object network, call it map, 172.16.96.32, and here the host of the real IP, the host is 2222, although it's sitting outside, which doesn't really matter. However, when you define your order of interface, make sure you have the outside as your real IP, because that's what it is, your IP on the outside. And static 172.16.96.32, and you can specify DNS. Okay, so here just to demonstrate what I talked about earlier as far as the two separate mapping process or natting process for the source and destination. So for anything that we have defined already in the Object NAT, it will still be applied for the source NAT. But in addition to that, if there's a match for the destination NAT, which is the second step of the process, that will also be performed. So there will be one match for source NAT and a second match for a destination NAT. So we can use any loopback address that we have for testing. And you can see telnet 172.16.96.32. Let's try loopback 0. See, it went through, and who, and it gets natted to 11164, which was what we originally did for the static NAT 11164. So the first natting process was the source. At the same time, the destination, although it's defined in a separate command, it was also performed. Actually, destination is right here. Okay, and just to prove that, we can do a packet tracer, which will give you a better picture of what's going on inside the ASA. Input inside, we'll just do TCP, which is what we just did, and the IP coming from is 172.16. Let's pick a different one this time. So let's do Dynamic NAT, which is 32.39. Port can be anything. Just give it something to 172.16.96.32 and port 23. Okay, let's step through this. So the first thing, the ASA check its access list, and it's always allowed by default from the inbound to or outbound, or inbound into incoming into the inside interface. The second thing it did was unnat, because we have a destination NAT, so that gets undone first. So here it matched an object network that we created with the outside inside, and the IP gets untranslated from 96.32 to 2222. Okay, next it performed the source NAT. So it matched a separate NAT configuration that happens to be a dynamic NAT pool that we created, and the IP 32.39 was translated to 1.98. So you can see it's a two separate process. So show NAT. Okay, the last thing we want to try is Identity NAT. We're going to do object. Here we're just going to try something different, which is creating object group network. We call object OBJ internal. And we're going to do a whole network object of 172.16.32.0. So we're going to do like a catch-all kind of thing, and we'll see how that affects the order as well when you define the subnet instead of the individual host IP. So now we're going to do object network map 172.16.32.0. So subnet 172.16.32.0 255.255.255.0, and here NAT inside outside static, and the one that we created earlier, object internal, let's just do DNS. So the last loopback that we can use that has not been used yet is loopback 6 that we can use to test. So ping 1111 source loopback 6. Yeah, we don't expect to have the reply coming back because if you look at R2, you see the IP, source IP is coming from 32.45, and R2 doesn't know anything about that IP. But just to show you that the NAT command that we configured works, let's see where it is. Right here. So static NAT, and this one translated hit. While we are looking at this table, you can see the order has been put together automatically by the ASA, so it doesn't really show up on the same order that we configured the NAT. So starting from the top, you have the more specific, which is the static, outside, inside. So destination NAT comes first, and then followed by a regular, or the port forwarding, or static PAT. So static PAT is more specific than a regular NAT, static NAT, because of the port. And then followed by static NAT. That's the network NAT that we did. Order 3, order 4 is, that's just also, identity NAT is basically a static NAT. So that's, but because you can see, because of the subnet that's less specific than the one that's redefined in number 3, it gets put in 4 underneath that. So the ASA kind of reorder that automatically for you. And then it's finish off with dynamic NAT. So here's dynamic NAT, which is again more specific than the dynamic PAT. So okay, so that's how the ASA put different kind of NATs into orders. And that's only happened again in section 2 and not section 1 or 3, which we would look at in a twice NAT video. Okay, so that wraps up our video on Object NAT. Thank you for watching LabMinutes.com, and I'll see you guys in the